Hey guys, Corey back here with Iconic Metalworks, and I've been getting a lot of questions lately with the bead roller that I've done other videos on, and some of you guys are really wanting to build one. So I took the time out of my schedule to try to present this to you. So I removed the top shaft out of the top. I've got two people that I'm going to kind of shout out to once I go into this, but you guys will really see how this top shaft works. One of them, and this person's not the only person, but they always think that this is a two-piece shaft, and up here there's some type of something going on. So I'm going to go over that with you guys in this video. And then another guy has an issue with the gears. They're not meshing, it's too fine of a gear or whatnot like that, and I'll go over that too. So let's jump straight into it. I took the shaft out so you guys can see it. And I'm going to kind of get the camera and I can talk about it up close. So for Janso 1745, I've been replying to a lot of your questions, and you're concerned about this, the pinch down, what presses the dies. This is just basically a square block of material that's been machined out. I have bronze bushings inside. It is locked in from this being down, machined down as of right here with a lock collar. This shaft cannot go back and forth, but it can spin. So the question that he had, so for some of you guys, is how do you get this spring and all this stuff to slide with the shaft? It's not a two-piece. And like I told him, I said, you guys can't overthink it. So what I ended up doing, I grabbed I believe it's an 1/8" piece of welding rod. And this is the way I came up with it, and it works really well. So I bent it in the vise to a hard 90 and figured it out. Once your gears are centered to where all your dies are basically, straight with each other, this is where you'll determine where you need to put this little U-shaped bracket. All it is so this spring, which I'll walk over to the camera here in a minute, it could slide. So this is a total of, I think I did it right around 1 7/8" overall. But if you could hit center on this, what happens is when this thing slides, this spring stays stationary up in the frame, but it will not stay stationary here, which allows the shaft to slide, but it's still pulling up to create the tension to when you wind it out, it sucks it up, and then obviously your jack screw is what I'm going to call it, is what's driving it down. But a lot of you, I'm not going to take off the bottom side, but just to get in, this is how I have the back set up. This is all 1 inch because the ID of the gear is 1 inch and it's keyed, but there's 2 lock collars here. This is the back bushing. And as you can see, these are my handles that come in here that are on the low end. And it's threaded on the bottom side of this bushing, which I'll take this one out so you guys can see. And I'll come up here. It's going to be kind of hard to do the camera. Okay, as you can see, that hole is not tapped all the way through. It's tapped all the way through, but it's not drilled all the way through. And it's on the bottom edge of the circle. These here are just sets or locks. What do they call them? It's just a ring, and it's drilled and set screwed. So this thing just spins right here. Now what I'm going to do, as I take the gear off, you guys can see it's keyed, and then this is for the groove, for the set screw. The best way I can describe this gear, this is 1 inch wide. And what I'm going to do, the other gear, if you could picture it here, it's going to be directly below it. Okay, this is what happens. When you slide the gear off center over, you want to end these gears to where there's a 1/4 inch of this gear, so that much of this gear and that much of the other gear are offset. So your other bottom gear, which is stationary from the motor drive, will be here. If this shaft is shoved back, it'll be here and it'll ride on that much of the gear. Now, if you shove the shaft the other way, your stationary gear will be here and it'll ride on a 1/4 inch of this and out. So if this is 1 inch and you put a 1 inch gear out here, that's a total of 2. Well, if you come back a 1/4 of an inch, that's 3/4 of an inch, and then if you do it on the back side, that's 3/4 of an inch, which gives you an overall 1 3/4 inches of travel. Because if you go all the way back, now you're offset here, and you're driving back here because it's moving the shaft from the point that it's locked down. So that's what I wanted to kind of share with you guys in this video. And this deal here, the gear situation, what a lot of people don't understand, this one's for David Cooper. Hopefully you watch this video. You don't need the part numbers. And I'm going to tell you why, is because my dies are from Lassie. They're metric, okay? I don't know what particular bead roller or what dies you are using. If you're using Lassie's, you can do it this way. This is the way I did it, and it works out fine. The gears are 1 inch wide, okay? The big thing is you need to find the biggest die that you're going to run. Obviously not like a tipping die, but like all my dies are pretty standard to the same size. So what I ended up doing, grab a tape measure, measure your die itself. Outside to outside. This one's roughly 2 3/8. Okay, now watch. This was the closest gear I found that wasn't custom made. It's store bought. Now if I can get this is right around 2.5 inch OD. And it works totally fine. The gear has to be the same size as the die. And some people will try to tell me that it doesn't have to be. It does. Because what's going to happen, you want, and for this motor and everything to work correctly, it's a 1-to-1 ratio. So every time that this thing spins one time, this thing spins one time. But if you go with a taller gear, for one, you're going to get in a bind building this box back here because it's awful close. Okay, and if you use a smaller gear, this thing here is going to spin 4 times, which is going to make this thing, if you can't control your speed like I can, it's going to screw everything up. So for David Cooper, you want your gear to be the same size as your dies, or relatively really close. Okay, and so the way that I kind of did this is down inside these chamfers of these gears, the gear is 2 3/8. The outside of the gear is 2.5. So when you put this, so it's when it's totally meshed, when you put this gear up, the only thing that sticks up are the gears themselves. The mesh, like the groove down there, fits perfect. So that's for David Cooper. The gear that you want to run just needs to match this. That's why you're having the problem that you're having. If you can find the gear that you want, and per se, I'm just throwing this out there, this one's 1 inch. Lassie's new bead roller says it has 2 inches of travel, overall travel. Mine has 1 3/4 inches, his old one's had 1 3/4 inches. It's all done in this gear. So if you can find this gear, this size, but instead of 1 inch, 1.5 inches wide, then when you put it in your machine, you will actually, on this piece here where those handles slide back and forth, you will actually cut that, a 1/4 inch further this way and a 1/4 inch further that way, which gives you that much more travel each side, which is a total of 2 inches. So what I wanted to share with most of you is this is the ultimate piece that everybody gets boggled with. They say, is this a 2-piece deal where this thing kind of like a telescoping shaft and all this stuff? So basically it just keeps the drive and then you can move this. No, it's all done back here on these handles. When you loosen this handle back here in the frame, it allows this whole thing to slide and it's a direct drive all the time. So with that being said, I really hope this is some helpful information to a lot of you guys that are having questions. Like I said, I just took the time out of my day to take the machine apart to better show you guys, because last time in another bead roller video I had, it's just basically going over how to build it and stuff like that. But with it apart, you guys could actually see exactly how it's looking now. And I hope this helps you guys tremendously. You guys could probably come up with another method. I know Lazzie's had a spring up there just like mine, and with this shaft moving like that, this is the only concept that I came up with for a spring. Now, the screw jack, they do make them like a mill bed where this is cut in a T cross, and you could actually put it in there, so as you wind it up, you wouldn't need this. But Lazzie's isn't that way. He has like a swivel foot, and that's what mine has. But if you had a T-bar that was machined in this, and you had a T-bar that, I guess that was like a swivel foot, but it swiveled inside there, when you crank up your handle, it would suck it up, and when you crank it down, it would suck it down. But I didn't want to get into that. It's easier to replace this spring when it wears out than it is to have something galled in there and you can't get it out of the machine. But this is really easy to maintain. And like I said, like I kind of went, this here being 1 inch in the back, this here bushing has no bushings in it. That's why it has a grease zerk on it. So I maintenance my machine, you know, a couple squirts of grease, and it gives it that bearing that it needs. This, on the other hand, and the one in the bottom, for the bottom shaft, it has a press-in bushing because these shafts were cut down to 20 millimeter. I didn't do it back here because on the motor, like I've said in a previous video, it has a 1 inch hollow shaft keyway motor. So when I started, I mean, if you want to do more machining, more power to you. Start with an 1.25 inch shaft. The only problem is this one comes out that way. If you start with an inch and a bigger shaft, the bottom shaft, that bottom bushing that's in the front of the frame is welded in. Okay? Same with the back. So the back has a 1 inch too. That bottom shaft, I have to pull this motor off, and that bottom shaft comes out this way. It cannot go out the front. So basically when you're assembling, you shove it all the way to the front where it locks out. You shove it in on this side. This side has another lock collar that basically just lets it run in between those two welded on bushings that are built in the frame. And then my gear slips on, and then the shaft slips, or the motor slips on. And then once it's all tied down with the keyway, this is locked and loaded and it can run. So I hope this video helps you guys out, especially with these two people that you kind of, you know, reached out to. You guys had questions. You guys can phone me. I'm totally fine with that. And I have had some of you guys do it. But what I'm trying to do is just show you guys the basic principles of this. And like I said before, I think I said it to Janzo 1745, don't overthink this. It's just one of those things that it could be complicated. So I hope you guys like this video. If you're not a subscriber, go ahead and click the link below. I'd appreciate it. If you guys have any other questions, feel free to reach out to me. But this right here seems to be boggling so many people. And if I could help you guys out, I'm more than willing to. But now that you guys could see it and it's a clear picture, I hope you guys could really use the information. So I'm going to log off here with you guys. If you're not a subscriber, click the link below. I'd appreciate it. You guys could follow my other social media feeds and stuff like that. But I'm going to log off with you. I'm going to show you guys up close with a walk around deal with the camera before I get off. So you guys stay tuned, and I'll have some more videos coming in if this ice storm ever stops coming our way. So I'll show you guys the shaft up close. So as you can see, the back is keywayed, and then I cut that groove for the set screw. So basically it's a no-brainer. It slides on. I put the set screw in, I wiggle the gear back and forth, screw it in a little bit. When it cannot move no more, then it's pretty much locked in its true line. This is that bushing I was telling you about. And as you can see, it's basically on the lower half of the circle, or the hole that's bored through it. And then it just slides on this. I just put a little bit of grease on both of this, and this slides in the frame, which is right in there. But as you can see, my gears are really tight to this box, and I had to flare these edges out. Lousy's is straight, so I don't know if he maybe used a thicker plate here. He may have used something, I used quarter, he may have used maybe 5/16. So it just gives you that extra so it's straight. But then as we get up to this bushing, don't mind this. My first deal, what I was doing, I was gonna put a keyway in here to let it slide up and down, but then I realized inside the frame, I realized it wouldn't be able to slide back to forth. So I kind of welded some of it up, and you don't see much of this, it's all up in the frame. But that is the mechanism right there that allows this whole shaft to slide with that spring locked in right here. And the way I lock it in is, let me find it. Well, it just happened to disappear. But anyway, it's just a dowel rod. And as the spring, there it is. So as the spring protrudes through with the hook that comes up through here, I just slide this through the spring and it hooks around that, and then the spring pulls down or pulls up, or however you want to do it. And it just sits there. And if I ever need to take it apart, I slide this out, the shaft drops, and then I unhook the back gear. And then my bushing, I had it longer, but the problem at the bottom of the frame, so you guys could see all this stuff up close, it was already welded together, and there's no way I can get in there and cut this out further. Okay, so what I ended up doing is I cut this bushing down, faced it off, put the bushing back in, and I added a small lock collar, which is 1 inch in diameter, so it can slide. It's still the same diameter as the shaft, but it keeps this edge never changed. It's just I shortened this and made this to where now it can drop. So when I tighten it down, it actually flies about right here, maybe a 1/4 inch away from there. So that bushing will actually drop below this frame a little bit. And it's just the nature of the beast. But that is how it slides back and forth. It is not a 2-piece shaft, as you can see. These handles, obviously, if you look in the other video, they go in here. I just tapped it, I just threaded it in so you guys can see the whole art of it. When it's kind of, you don't see this, it's all in the frame. The only thing you see is this and the output shaft where the dies go. So, hope this video was you know, definitely an educational deal for some of you guys trying to build these. Like I said, go over there and hit the subscribe button, hit the like button, leave some comments. I'll reach back to you guys. I appreciate it.